Hey everyone, and welcome back to the EdgeVerse TechCast. This is your go-to spot for everything related to NXP software, tools, and developer enablement across our processors and microcontrollers. And I'm one of your co-hosts, Kyle Dando.
And I'm Bridget Stone. Thanks for tuning in. Today we're diving into something that's generating a lot of buzz right now, and that's Agentic AI at the edge and how devices can start working together more intelligently.
That's right, Bridget. We're talking about Model Context Protocol, or MCP for short, and how NXP is bringing it all the way down to the microcontroller level using Zephyr.
Which means even smaller edge devices can start participating in these intelligent systems, not just the big processors running massive AI models.
Exactly. And to help us unpack all of this, we're joined by someone who's been right in the middle of building the solution.
Joining us today is David Piskula, Systems Enablement Engineer working on Dynamics RT and Embedded AI Technologies. Welcome, David.
Hello, I'm David. I'm an engineer from Czechia in Europe. One of my areas of focus is embedded AI, which is how I got into the topic of MCP, which is another acronym. This one, as Kyle noted, stands for Model Context Protocol.
All right, David, before we dive into protocols and AI agents, let's start with a classic EdgeVerse question. When you meet someone for the first time and they ask what you do, how do you explain your job?
So, as a systems enablement engineer, I have three main roles. One of those is the representation of NXP, which I do by supporting customers who have questions or face problems when using our devices. I give training sessions and general presentations to customers and customer-facing teams within NXP. I also attend tech events like Embedded World. Another role is serving as the first customer within NXP, which means I take part in field trials, I review our documentation, and give general feedback to our R&D organizations when using our products.
So you're basically the person who breaks things first so the customers don't have to.
Exactly. And finally, my job is also to create demos and reference designs and write application notes that help customers get started or that hopefully inspire them to use our technology for their projects. And part of this is developing the MCP library for Zephyr.
That's right, David. I was recently talking with Alex Rodriguez, your counterpart, and he mentioned to me all the great work that the two of you have been doing, specifically with the MCP. So can you explain what the two of you have been trying to solve for customers by providing this MCP library?
Sure. So in general, NXP has been focusing on edge computing for years now. And the key advantages of doing computation at the edge, meaning on the devices at your location without the need to connect to a remote server, are better security, more confidentiality, and lower latency. All of those can be applied to AI as well. The trade-off, of course, is that an embedded device has less power than a data center, but thanks to devices like the i.MX 95 and the ARA discrete neural processing units, or DNPUs in short, from the recent Kinara acquisition, you can run even LLMs at the edge these days.
All right, so many of our listeners are familiar with LLMs. More and more people like myself are using these tools to summarize documents, maybe a podcast, or get help explaining code. I know a lot of our developers are using like a Cody extension that helps them their daily job. But how is what you are working on similar to these ChatGPT and Gemini tools that people are using in their everyday lives?
Our DNPU devices can run models that are much simpler than ChatGPT or Gemini and similar. But when you narrow their focus on a specific area, they can be just as effective. When you distribute a complex task to LLM agents, that's when the real magic happens. This is where the Model Context Protocol comes in. As the name infers, MCP is a communication protocol that standardizes how agents should interact, not only with each other, but also with other entities or devices that don't necessarily need to have any AI capabilities themselves.
All right, so let's unpack this a little more. How does MCP actually help these edge devices participate in a system with AI agents?
MCP specifies the format of JSON messages and the communication exchanged between an MCP client and an MCP server. The MCP servers are entities that offer various services, like tools or tasks that can perform actions, say turning on the light. MCP clients are the consumers of these services. The beauty of a protocol tailored for LLMs is that you don't need to hard code or set up anything manually. Instead, the MCP server just needs to tell the MCP client, using normal human-readable language, what it does and how its services can be used. It's completely plug and play. You could have a smart home with agents taking care of monitoring temperature, power consumption, presence of people or pets, even controlling your appliances. Then you buy a new fridge, for example. All you need to do is connect the fridge to your home network and tell your agents, hey, here's a new device, check it out. And the fridge and the agents will automatically exchange information about what the fridge can do and what it allows agents to do with it, like control the temperature, monitor the contents, notify when something isn't right, etc.
So devices become self-describing tools inside the system.
Exactly. The fridge would literally send a list of tool descriptions like temperature tool, this tool provides the current temperature in the fridge, or contents tool, this tool provides a list of contents. Input arguments can specify if you want specific categories like vegetables.
Amazing. Can you provide a second application that shows the benefit of having this MCP solution?
So another interesting area of application can be factory automation. Imagine a network of devices, each with a specific task like monitoring the security and safety of a designated area, planning the logistics of moving large objects around the building, or managing crisis intervention. Some of these devices can have an AI agent running on it, completely offline, evaluating the situation, while others can be MCP servers with other tasks, like a robot that moves boxes around with an MCP server that lets agents control it remotely, or just doors that open when an agent gets notified by a camera or other sensors that you're coming.
And do all of these applications require devices like the i.MX applications processors with an ARA DNPU?
Perfect leading question, Bridget. Let me answer it. While the i.MX devices coupled with the NPUs can take care of running the agents, they would be very much overkill for operating the simpler things like alarms, lights, doors, displays, whatever. This is where the Zephyr MCP library can shine instead. It brings the protocol down to the microcontroller level, and better yet, Zephyr makes it hardware agnostic.
Terrific point, David, on the benefit of using Zephyr. So not only is it ideal for microcontrollers, but it allows that developer to select the device ideal for their application. They can look at parameters like processing power or the memory of a device, maybe the amount of GPIO, and they're always looking at the cost of those devices. So by you guys using Zephyr for this MCP solution, it allows those developers to use this application across the microcontrollers that they select. Now, what has been the hardest problem that you've had to tackle? Where have you and Alex spent most of your time developing this solution?
The hardest problem was taking a protocol designed for mostly high compute devices and AI agents running in the cloud or on PCs and implementing it to run on a resource-constrained MCU. We had to carefully choose what to spend our compute and memory on and needed to be a bit creative when it came to how we serve multiple concurrent requests.
All right, so after you tackled those challenges and you prioritized, what have you found are the biggest benefits that the listeners can appreciate?
They will find two big benefits of our library. One, that it's Zephyr-based and completely device agnostic. All you need is Wi-Fi or Ethernet capabilities and you're good to go. We haven't tested it on super low power devices yet, but the MCXN, for example, works like a charm. And the second benefit is the plug and play way the protocol works.
Wait. You just said plug and play, David. That sounds too good to be true. So can you share maybe an example of why this term fits for this application?
Sure, I have a great example. But first, remember, Kyle, I'm in engineering, not in marketing, so hopefully the listeners will accept my credentials to make such a statement. When I was testing the solution with NXP's EIQ Agentic AI framework, I implemented an example demo for controlling an LED on an MCX freedom board. All I needed to do in my demo application was program a function controlling the LED. add a description of what the tool does using a brief human understandable explanation, and register it as a tool into the Zephyr MCP server. In this example, I described it as this tool controls an LED on the board, send on, off, or toggle commands to control it. The MCP server maintains a list of registered tools, and once you plug it into the same network as the EIQ-AAF devices and tell the EIQ-AAF solution that a new server is available, the information exchange is automatic. After that, you just tell your agent, turn the LED on, and it knows exactly what to do based on the provided description. Plug and play.
David, this sounds very cool and something developers will absolutely want to try. I'm sure what you have explained took our team countless hours. We're so lucky to have dedicated, smart guys like yourself making NXP devices intelligent for themselves. So, how do you suggest developers get started? Is there a Zephyr project that they can evaluate?
As of right now, everything is on the NXP upstream fork of the Zephyr repository, and a pull request into the actual Zephyr project upstream has already been submitted. This includes the library itself, unit tests, and a simple example application for controlling an LED and sending hello world messages. This initial example, as well as future more complex demos, will be added to the application code hub once everything is ready, so it will be very easy to find and download.
All right, David, we'll work with you to get those links into the episode notes. We know our listeners like to click through and get started as quickly as possible. It sounds like this is going to be a very busy year for you enabling all of our devices, and we'll have to get you back on, and then you can answer some of the questions that people pose in the comments and maybe go into a little bit more of the performance and the metrics of this solution that you presented. But again, thank you so much for joining today.
Yeah, no problem. I enjoyed sharing what we have been working on, and it's been fun, so I'll definitely come on again if you invite me.
Yes, David, thanks for walking us through this. You've helped demystify MCP and showed how devices at the edge can become intelligent tools in a much larger system. And it's another great example of how Zephyr continues to expand what developers can build on microcontrollers.
And you ended your description by describing practical examples of using MCP to control an LED or print hello world. So listeners can get started themselves with these Zephyr examples that you described.
Thanks again, David. And for our listeners, I encourage you to share this episode with a friend. We appreciate your support and our efforts to get you updated on all things NXP enablement. If you have any questions from today's episode with David, leave them in the comments, please.
And until next time, keep innovating. Make sure to evaluate the NXP MCP for MCX, MCUs, and we'll catch you on the next EdgeVerse TechCast.